Hello and welcome back. This is video number 2 out of what I think will be 4. This is again about equations, and we are going to look at Hegarty task 178 and 179. Now, I want to do something really basic to do with equations before I go any further, and that is how to solve a one-step equation that involves either multiplication or division. So I'm just going to put 4 examples. I'll do them. I'll set you some to try, and then I'll go through those answers, and then I'll move on to well, actually what I'm going to do is I'm going to move on to a couple of other examples where I will show you the balance method and the bar method, and then finally we'll get to Hegarty. Okay, so without further ado, here are the 4 example questions. So these are all, because they've got equal signs in them, these are all equations. Now they are quite simple equations, but I'm still going to show you exactly how we solve them. So number 1, 4x equals 12. Number 2, 7x equals 371. Number 3, x over 2 is 4. And number 4, x over 6 is 3. So let's look at number 1. If the idea to solve an equation, what does it mean to solve an equation? What is the solution? The solution is we want to end up with x equals, and we want to know what the number is that x actually equals. Now, most of the time when you're solving an equation, you will end up in a situation where you've got some number in front of the x, and then equals, and then some other number, right? So in this situation, I have 4x equals 12. Now, what you do in this situation, when you might have started with something more complicated, and we will look at examples that start off in a more complicated way, you will end up, if you follow the correct methods and follow the correct routine, you will end up in a situation where, as I say, you've got a number in front of the x and then equals a number. It could be the other way around. It could be 12 equals 4x. It doesn't matter which way around it's written on the equal sign, but I'm going to keep the x's on the left hand side just for the time being. When you're in this situation, you divide both sides by whatever is timesing the x. So in general, when solving equations, you need to do the same thing to both sides of an equation, and I'll talk about that in more detail when we look at more complicated equations. So if I add 5 to both sides, if I add 5 to one side, I need to make sure I add 5 to the other side. If I times both sides by 6, if I times one side by 6, then I need to make sure I times the other side by 6. If I take away 2x from one side, I need to make sure I take it away from the other, etc. You need to do the same thing to both sides because it starts off balanced, right? Whatever 4x in this question is equal to 12, it's perfectly balanced. So if I do something to the 4x, I also need to do the same thing to the 12. Otherwise, if it was a set of scales, it would tip the scales, right? I want it to stay balanced. So the thing that you do in this situation is you look at the number in front of the x, and you divide by that. So I'm just going to write it like this. I'm going to put a fraction line, because remember, the line in a fraction means divided by, and whatever you're dividing by goes on the bottom of the fraction. It's the denominator. I'm going to divide both sides by 4. I'm going to divide by 4 because that's what's timesing the x. Now 4x, when I divide that by 4, that gives me x. And in general, this is going to work. So 7x divided by 7 would be x. 12x divided by 12 would be x. 103x divided by 103 will be x, etc. So this side here is literally just x once you've done this. Okay, because basically, you can think of it as I've started with x, I'm timesing by 4, and now I'm dividing by 4. But those are inverse operations, so they undo each other. So I'm just left with x. 12 divided by 4 is literally 3. It's a number. That's the answer. It's 3. So the answer to this one is x equals 3. That's the final answer. So that's what you would put as your final answer to solving this equation. 7x equals 371. I need to divide both sides by 7. And so I might use the bus stop method, or since I'm at home, I can get away with, assuming this works, yes, I could use a calculator. So 300 and, let me just put it on the screen for you there, 371 divided by 7 is 53. So my final answer here is x is 53. So yes, I also can put a calculator on the screen, so sometimes that'll come in useful. Right, number 3, x, and then this line is of course a fraction line. It means divided by. X divided by 2 equals 4. So whatever x is, I'm dividing it by 2 and I'm getting the answer of 4. So I need to do the opposite of dividing by 2. If we think back to number 1 and number 2, I am actually doing the opposite thing. Here, x was being timesed by 4. So I do the opposite thing. I divide by 4. That's what gives me x. And I do it to both sides. So that's what gives me x is 3 for that one. In this question, x is being timesed by 7. So to undo that, I divide by 7. And of course, I do that to both sides to keep it balanced. And that's what gives me x is 53. What's happening to x in this question? It's being divided by 2. Not timesed by 2, divided by 2. To undo that, you do the opposite of division by 2. You times both sides by 2. So I might just put it here that I'm going to times both sides by 2, because that's the opposite of dividing by 2. X got divided by 2, but now I'm timesing by 2. That's going to give me back to x. That's the point. I want 1x, and that's it. And then 4 times 2 is 8. And that's the answer. If you think about it, 8 divided by 2 is 4. So x is 8. And then if I look at this last one, why don't you pause the video and tell me what you think you need to do? Or rather, think it out loud to yourself. Write it down. Hopefully what you came up with was that you times both sides by 6. I'm going to undo this division by 6 by timesing both sides by 6. So this gives me x equals 18. 18 shared by 6 is 3. Right. You need to be really confident at being able to answer questions like that. So I am going to just write up 4 questions for you to try. And then I'll invite you to pause the video and then I'll just answer them. And I'll answer them quite quickly. Okay. So number 1, can you solve 2x equals 16? Number 2, can you solve 8x equals 56? Number 3, can you solve x over 5 is 12? And number 4, can you solve x over 12 equals 4? So pause the video, have a go at those questions, and then, well, press play again to check the answer. Right, in the first one, I'm going to divide both sides by 2, and I'm going to get x equals 8. By the way, this could be left. Imagine this didn't give you a nice answer. If instead it had said 3x equals 16, for example, you could leave the answer as 16 over 3 in that situation. And that would be fine. That's just an answer that's an improper fraction. When it can be simplified, though, we should simplify it. And certainly 16 over 2 can be simplified. We would just write the answer as 8. Right, in this one, I would divide both sides by 8 and get x equals 7. In this one, I'm going to times both sides by 5 to get rid of this division by 5, and I'll get x equals 60. Just underline my answers. And then in this last one, I'm going to times both sides by 12, because whatever you do to one side, you must do to the other, and I get x equals 48. And that's that. Right, hopefully everyone's okay with that sort of question, because once you're okay with this, we can sort of begin adding the layers of complication, okay? So I'm going to go through a couple of additional examples that are a little bit more complicated, but not too much more. And I'm going to show you the balance method and the bar method, and then maybe start the Hegarty task. I am actually beginning to think that this is going to stretch to even more than 4 videos. Maybe I'm going to stop saying how many videos it's going to be and just tell you at the end, all right? Because there's clearly a lot that I actually want to make sure that I'm getting in. Or maybe we'll just make this a longer video and try to keep the other 2 shorter. We'll see how it goes. Anyway, example 1 is just going to be a one where you can maybe just think the answer up in your head, and that's absolutely fine. If it's a particularly simple one, no problem with coming up with the answer in your head. Okay, I want to use this as an example to show you a method. Okay, so the bar method is what I'm gonna show you, and the idea is that you can use the bar method to answer trickier questions. Okay, but I'm going to start with a fairly straightforward one to show you how it works. Okay, so x add 7 is 20. So something add 7 is 20. So of course, spoiler alert, the answer is going to be 13. But let's see how the bar method works. Okay, so what you do is you draw 2 bars. You don't worry about how long they are, but you do make them, when you draw them, you try to make them about the same length. Okay, so I've not done that with a ruler. I've not done that with any particular length. I've just drawn 2 bars, one on top of each other, where they are about the same length by sight, right? Like I'm looking and they're about the same length. And what I do is the first bar is going to be the x plus 7, and the second bar is going to be the 20. I mean, I could actually do them the other way around. As I said before, it doesn't actually matter. But I'm just gonna do it in that order because that's the order it's written. So I'm gonna split this bar into 2, and it doesn't really matter where I put that line either. It doesn't matter. I'm just gonna put it there because why not? This bit here is going to be the x. So we're pretending we don't know that x is 13, but anyway, bear with me. This is x, so whatever x is. And then this bit is 7. And then this bar here is literally just one bar, doesn't need to be split up. And I'm just going to write 20 in there. That's what I'm going to do. I'll show you another bar method example with a harder question in a bit. I'll just focus on this one for now, just to show you what we now do. So what we do is we kind of line up things that we can kind of, well, almost with a pair of scissors, chop off and get rid of. And how this is going to work is you're going to be able to cancel numbers with numbers. So remember from video 1, I talked about number terms and I talked about x terms. So you're going to be able to kind of cancel out some of the numbers. And then if it was a more complicated question, you would be able to cancel off some of the x's as well. So I'll show you a question like that. Perhaps not in this video, but certainly in a later one. So if you notice, this 7 here has to balance exactly with this part here, which is also going to be 7. So what I do is I literally just draw a line going straight down, and I pretend that I'm literally going to cut up there. So I would chop off this 7 from this part, and I would also chop off this part, and of course that, if it's totally fair, it's totally balanced, this would be 7. and it's been chopped off. So it's like there's a little pair of scissors. It's chopped it off. And what some people like to do is they like to draw it out again, but without the bit that's like with the bit that's been chopped off gone. So I might do that just for this one. So what do I now have after it's been chopped off? Suppose I put a bit of orange in. I'm only going into this extra detail just for this one. So this is X, and then this has also been chopped off, or chopped. There's been a bit chopped off it. Like these bits we throw in the bin, right? We just get rid of them. This isn't 20 anymore though. It started off as 20, but we've chopped off 7. So I need to work out 20 take away 7, which is of course 13. So what I'm actually left with over on this side would be 13. And now what we actually have is exactly what X has to be. X has to be 13. And that's how I would write my answer. X equals 13. And that's literally my final answer. And that's it. In terms of how I would write this down without a bar method, and of course you can pause the video and make notes. So if it feels like I'm rushing, you can always just press pause and you can rewind and you can do all of that kind of thing. So that's there, but I'm going to move it. Let me write x plus 7 equals 20 again. And just kind of do the same thing, but without drawing the bars. So what I would do is, I'm going to take away 7 from both sides. So underneath, I write it underneath the number term. And I'm still left with the x. If you remember from the picture, the x is still there. The x hasn't gone. And 20 take away 7 is 13. And then there you go. There's my final answer. And I managed to do that one without drawing any bars. But the bar method is a really, really good method for learning how to do equations, and I will show you some more of the bar method. So I'm going to show you now example 2, which is going to be 3x add 5 equals 29. So already a little bit trickier. You might be able to work out what x is just by looking. You might be able to work out that first you need to take away 5 and then you need to divide by 3. If you can't see that, that's fine. Let's draw the bars that correspond to this equation. So again, I draw the 2 bars. This one here is going to again be split into 2. There's a 3x and there's a 5. The bar method isn't as useful if we have things like take away. If this was 3x take away 5, this would not be as easy to draw. We'd have to really think about what to draw. So the bar method is really more useful for when you're learning about sort of how you balance out the numbers and then how you balance out the x's. So I'm just going to focus on this sort of question for now. So I've got 3x and 5. 3x and 5 is, of course, 29. You can have a go at this yourself, of course. You can always pause the video at any point, have a go, and then watch the video to see if you were right. So I'm going to chop off the 5. And this time I'm not even going to draw the bar again. I'm just going to fill it in. Right? Because we're all about not having to draw things lots of times, if we can help it. So this isn't actually 29 anymore, right? This is now 24. And what I'm left with is 2 bars, a 3x and a 24. So let me write that down as a little equation. 3x equals 24. But aha, we've just seen how to answer questions like this. Now, I'm just going to divide by 3. So this is x equals 8. X equals 8. Right. We're up to nearly 20 minutes. So what I'm going to do is not actually commit to how many more videos it's going to be, but I'm just going to promise you that we will get through what I said we're going to get through, and I will try to ensure that the videos are not too long, because I think what's better is if we had more shorter videos. So I've introduced the bar method in this video, so this is what I'll call the video. I might start the next video with a few more examples where maybe they're a little bit more complicated, and then at some point we'll do the Hegarty. Who knows when? Hopefully next video. Anyway, leave a like if you found this useful. Certainly give it a go yourself. In the next video, I'll give you some questions to try. I'm just conscious of how long these videos are. I don't want them to be too long. Right, I'll see you in video number 3.